Welcome back. I'm going to be showing problem number 3, example number 3 from 11.7 strategy for testing the series in the concept video. Uh, the example sigma n varying from 1 through infinity, n times e to the negative n square, which uses the integral test. This problem was already done, but in that video, for some reason, this part of the video was cut. So I'm redoing this problem. So this is example number 3. Anytime you see e to the exponent of something or ln, one of the options for the test is the integral test. So here we have recognized that integral test can be applied. We write that down. This integral test has got um, some requirements. So we have to take f of x and show that f of x is positive, continuous, and decreasing on the interval 1 through infinity. Then second condition is to find out the improper integral and evaluate that integral. If that improper integral is convergent, then the series would be convergent. If the improper integral is divergent, then the series would be divergent. So let's first consider the relating function. As you know, relating function is a function uh, which, which is obtained by replacing the n with x in the series. So it is x e to the negative x square. So we can also write this as x divided by e to the x square. In the context of the problem, x will be always more than or equal to 1, and exponential function is positive as well. So we can say x over e to the x squared is positive and continuous. So we can make that observation here. F of x is positive and continuous on the interval 1 through infinity. Is it decreasing? Is f of x decreasing? Decreasing on the interval 1 through infinity or eventually decreasing? So for that, we have to apply the derivative test. Or you can call it increasing, decreasing test by the derivative. So let's find out the derivative of this f prime x. So for this one, we are going to apply quotient rule. So it is denominator times derivative of numerator minus numerator times derivative of denominator. When you do derivative of denominator, you will apply chain rule. So it is e to the x square. It's e to the x square times derivative of x square. Then divided by e to the x square, the whole square. On the numerator, e to the x square is the common factor. So we can take that out. The e to the x square times 1 minus 2x square divided by e to the x square times e to the x square. One of them will get cancelled out. The denominator is positive. So in order to show that it is decreasing, f prime x should be less than 0. It's possible when 1 minus 2x square is less than 0, or 2x square is more than 1, or x square is more than 1 half. By taking square root, you can get x is more than 1 over radical 2. One over radical 2 is approximately 0.7, so which tells us that x is f prime x would be less than 0 when x is more than 1. So f of x is decreasing on 1 through infinity, or we can say 2 through infinity, 2 inclusive. So it is eventually decreasing. So all the requirements of integral test are satisfied. Are satisfied. So now we have to evaluate the integral, improper integral. That will be our next step. Evaluate the improper integral. Integral 1 through infinity fx dx. This is integral 1 through infinity x e to the negative x square dx. As it is improper, we have to write this as limit as t approaching infinity, integral 1 through t, x e to the negative x square dx. This can be done by u sub x square equal to u. So 2x dx would be du. So the improper integral I by a substitution, its limit as t approaching infinity, integral e to the negative u. Then you have x dx. X dx is du over 2. This can be written as du over 2. Then if you integrate this, it becomes 1 half negative e to the negative u, that is negative x square, between 1 and t approaches infinity. So it can be written as negative 1 half e to the negative t square minus e to the negative 1, and t approaches infinity. When t approaches infinity, this part becomes e to the negative infinity, which will become 0. So it is positive 1 half. E to the negative 1 is 1 over e, so it is 1 over 2e. So which means that the improper integral converges. So we can say, so all the requirements of integral test are satisfied, which is f of x positive continuous decreasing on the interval 1 through infinity. In this case, it's 2 through infinity. All these are satisfied. And also improper integral converges. So by integral test, the series sigma n e to the negative n square converges. This part is the conclusion part. Hope this video helps. As I said in the earlier video, part B, I have done from the suggested exercise problems, I have done problem number 178 in this exercise. Please refer to the section videos for those problems. Hope these videos help.